Alright, Unit 11, Day 2, Linear Transformations, Rotations, and Reflections. So, this first little bit is a warm-up, and it's just asking us to write the equation of a line that would translate f of x, 2x plus 1, down 5 units. So, what we're going to do is, since it says down 5, we're going to subtract 5 from the y-intercept, and that's going to be g of x equals 2x minus 4. Alright? And then right here, it says to write the equation of a line that would shift f of x equals x up 6. So we're going to do g of x equals, and when there's no variable or no constant on the back, we assume that it's plus 0. So it's going to be plus 6. And there it is. Now, changes in the slope of the absolute value m affect the steepness of the line. If the slope increases, the line becomes more steep. Okay? And if the slope decreases, then the line becomes less steep. Alright? So let's take a look at these. Now, it says to graph f of x and g of x, and then describe the change from the graph of f of x to the graph of g of x. Be sure to label each graph. Okay? So this one says f of x equals x. Well, we know that's just the parent function, so it passes through the origin and goes like that. So let's go ahead and pull ourselves a line across there, like that. Alright? And then when it says to label it, all we're going to do is we're going to go f of x. Okay? So there's graph number 1. And then it asks us to go ahead and do 5x. So we go up 5 over 1, down 5, left 1, and that's all that we can do with that one. And we're going to call this, oops, come on. There it is. Okay. So there's that, and then we're going to make this one green, and it's going to look like that. Okay, so that's going to be our g of x. Okay, now as you can see, g of x is more steep. Okay, and then describe the change. So let's see, g of x is steeper by a factor of 5. Okay? That's the longhand way of writing that out. Okay? So, number 4. Let's take a look at this one. Okay? Says that we are starting off at 3x minus 1. Okay, so we're going to start off at negative 1, and we're going to go up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Let's see, 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, and we can go ahead and pull a line through there. Just like that. Okay, and there's that. Okay, now let's see, what else can we do? Well, we can go ahead and we can, excuse me, let's see, negative 1, and then we're going to go up 1 over 2, up 1 over 2, and then up 1 over 2. Okay? Same thing down here. Go ahead and round that out. There we go. Okay? And then we go ahead and draw ourselves a line connecting these dots. Alright? Y-intercept is still the same. Okay? But what we can say is the slope was decreased by 2, whoops, that's not 2, that's definitely a 3, by 2.5. And there we go. That's it. Okay? Just a couple of different ways to, spell that out and say, how it changed. Alright, so next, okay, it says to describe the change from the graph of f of x to the graph of g of x. Okay, so intercept is the same. Only thing that changed is our slope. So our slope increased by 1.25. Okay, 1 1/4. Alright, number 6. Okay, if we look at it, those are the same, but our slope decreased by 2. Alright, let's see. On this one, okay, on number 7 here, I see we got -2 and -2, so that's good, but what changed is the 4 and the 8. So what we could say is the slope was doubled. Okay? Because 4 to 8 is multiplied by 2, so that would work. We could use that. Okay? And then on number 8, what we could say is, let's see, 1/2 and 2/3. Okay? Well, we gotta give some kind of notion of how much it increased by. So let's see, 2/3. That's really the same thing as saying 4/6 minus 3/6 equals 1/6. Okay? So we could just say that slope increased by 1/6. And that's it. Okay? Next up, it's asking us to talk about if m is positive, then the graph of the function goes up from left to right. Okay? Goes like that. Okay? If m is negative, then the graph of the function goes down from left to right. Okay? It will go like that. Okay? That's pretty obvious. So the graph and describe the difference from the graph of f of x to the graph of g of x. Be sure to label each graph. So on this one, let's see, we've got our parent function that's going to be going like that, and that's our f of x. Okay? And then we're going to have g of x. Okay? And that's going to be going like this. Okay? It's got a slope of 1 passing through the origin. That was really poorly drawn. Give me 1 second. Okay. Try this again. Let's see. Start right there. There we go. That's better. Okay. So, and then that's going to be g of x. Okay? pretty simple, pretty easy to see, and the difference is that it was reflected. Okay? And that's it. Pretty simple, right? Okay. Moving along. Okay. Number 10, we've got negative 3/4 x plus 2. So let's go ahead and get that one going. So plus 2, we're going to go down 3, 1, 2, 3, over 4. Okay. And we run out of room in that direction. So now we got to go back the other way. So 1, 2, 3, 1, 2, 3, 4, over here. Okay. And we can go ahead and pull ourselves a line across here like so. Okay. Now we got to draw the same line. Okay. Only thing that changed is the fact that it's not negative anymore. So we're going to start off at 2, and we're going to go up 3, 1, 2, 3, over 4, right there, and down 3, left 4. Okay, and then that's going to be, okay, and then we go ahead and pull our line across there like that. Okay, and we call that a reflection. Okay. Reflected. Okay. Alright. Now we start getting into the fun stuff, okay? Combos. So number 11, that has a slope of negative 3 passing through the origin. So we're going to go 1, 2, 3, over 1, 1, 2, 3, over 1. So right there, and right there. So that's our line. It goes like that. Okay, and that's going to be our f of x. Alright, now we're going to do the same thing, only for this line. We're going to see what we can come out with. So we go up 5, 1, 2, 3, 4, 5, over 1. We're out of room in that direction, so then we go like that. And we go ahead and we connect our dots. Now, y'all are going to look at this and go, oh, well, that's just reflected as well. But if you look at the equation, okay, you'll know that there was more to it than just a reflection. Okay? And this is g of x up here. Okay, so if you look at it, okay, not only was it reflected, but it was also increased as far as the slope goes. So slope increased by 2. Okay? It's more steep by a little bit. Alright? Next up, number 12. Okay? We've got, let's see, we're going to cross at negative 2. We're going to go down 1 over 4, out of room in that direction, so we have to go the other way. Alright, so there's that, and then we pull a line across here like this. Okay, and there's that. Now we need to go ahead and get ourselves the other line. Okay, oh, don't forget to label. That's f of x. Alright, next we're going to do g of x. So we start off at negative 2, go up 1 over 4. Same thing in that direction. Okay, and let's see. Pull ourselves a line just like that. And that's g of x. Okay, a florist charges $25 for a vase. Oh, forgot to do the description up here. Sorry. Okay, so this one was just a reflection. Sorry. Okay. Nothing else changed. Alright, so a florist charges $25 for a vase. plus 450 for each flower. The total charge of the vase and the flowers is given by f of x equals 450 plus 225. How will the graph change if the charge per flower is lowered to 40%, but the charge for the vase stays at $25? So this is pretty much the same thing as yesterday, except we're changing the charge by the flower. So it's going to be, let's see. So first off, we need to figure out what happens if we lower it by 40%. So that means we're only going to be paying 60% of the flower cost. That's 450 times 0.6. So that's 270. Okay? So let's see. That's right there. So our g of x now is going to be 2.7. Or rather, our slope of the new graph is going to be 2.7. So that's going to be g of x equals 2.7 plus 25. And that's it. Turn the equation of the line f of x equals negative 3x plus 5 if the slope is increased by 200%. So that means that we're going to multiply the slope by 2. So that's going to be, let's see, g of x equals, and we're going to multiply negative 3 times 2, which is negative 6. So negative 6x plus 5. Okay, now it says that to determine the equation if the line f of x equals 1/2 x minus 3 if the slope is quadrupled and the line is reflected over the x-axis. So that's going to be g of x equals, we know it's going to be negative because it's got a reflection, and we're going to quadruple. So that means times 4. 1/2 times 4 is 2. So negative 2x minus 3. And we're done. Compared to the parent function, describe how each graph changed. Okay, the first one, parent function is just a diagonal line that, let's see, passes through the origin with a slope of 1. Okay, just like that. Okay, and as we can see, this is just a reflection. Alright, now if we do the same thing here, draw ourselves a line going, oh whoops, totally didn't mean to draw that one. Okay, so like 1, 2, 3, 4, 5, 6, 7. Okay, draw it through the origin, should pop out on the other side in just the right spot, like that. Okay, something kind of like that. Okay, it's pretty easy to see that the slope increased on this one. Okay, now we need to put a by how much. Okay, so originally the slope was 1, and now the slope appears to be 3. So increased by 2. Alright. Okay, and then if we look over here at number 18, okay, we can go ahead and get our line going here. So like that, and then we can go ahead and pull ourselves a line across here. Just like that. Okay, now what we can say is that it was reflected and slope decreased by, let's see, that's a third, so we could say by a, let's see, by 2/3 would be fine. Okay? That would work. Alright, so next. Yay, multiple choice. Okay, So it says, on a vacation, the amount a family spends is described by the function t equals 1,000 plus 150 n, where n represents the number of nights in a hotel, and t represents the total cost of the vacation. For next time the family plans a vacation, that is described by the function 1,000 plus 125 n. What does this change in terms of the amount spent on the vacation? Alright, so 150 is how much they're spending per night. Okay? So, and then let's see, we've got 125 now that we're spending per night. So that means that we're spending $25 less per night. So let's see which one of these answer choices actually reflects this. So the number of nights spent in a hotel will increase. No, we went down. Right? The number of nights spent in the hotel will decrease by 25. Not the number of nights spent. We're not worried about the number of nights. Not worried about the number of nights. Okay? The nightly rate at the hotel will increase. Nope. The nightly rate will decrease by 25 would have to be the correct answer there. Alright, number 20. The function a equals 50 plus 25h models the amount a plumber charges for a job. In the equation of the function, h represents the number of hours the plumber works on the job, and A represents the total amount charged. The plumber plans to change the total charge. The new amount is represented by the function A equals 60 plus 25h. So that's what changed right there, the 50 to the 60. How much will the amount charged for each job be affected by the change? The amount charged per hour will increase. 25 represents how much he charges per hour. The amount charged per hour, nope. Charged per hour, nope. The total amount charged for each job will increase by $10. We did increase 50 to 60, so C would have to be your correct answer. A towing company charges a fee of $75 plus $2 per mile toward a mile towed to tow a car. If the car is towed X miles, the equation y equals 2x plus 75 can be used to find the total charge for towing the car. If the towing company reduces the fee for towing a car by 10% and increases the rate per mile towed by $1, which equation can be used to determine the new cost of towing a car? So the first thing that we got to look at, okay, is we're going to increase the rate per mile. Okay, rate per mile. So originally it was 2. If we look at our equation, 2, so that's going to be y equals 3x. So we can get rid of b and d right off the bat. Okay? Now we need to figure out what exactly is 10% of 75. Okay? So we're only going to pay 90% of $75. So let's see, that's going to be 75 times 0.9, and that's 67.50. So plus 67.50. So C is the correct answer. A landscaper charges a base fee of $200 plus $20 per hour to design a garden. The equation y equals 20h plus 200 represents the total cost of a landscaper's design for h hours of work. Which equation can be used to determine the cost of a design if the landscaper increases the base fee by $25? Now the base fee is, as stated right here, is 200. So that's this. So it would be y equals, it doesn't say anything about affecting the hourly rate, so 20h plus, and we're going to increase the base fee by 25%. So we're going to multiply 200 by 1.25. So that's going to be 250. So plus 250. And there's that. Alright, so a couple paid $70 toward the cost of a new freezer, and will pay off the remaining amount in 8 monthly payments of $60. how will the number of monthly payments be affected if they pay $70 now and $80 each month? So 70 plus 8 times 60. Okay, so let's see, 8 times 60 is 480. 480 plus 70 is 550. So we're going to have 550 equaling our total. Now it's wondering, okay, well, what happens if we do 70 plus X times, and we're going to pay $80 a month now. Okay, and it still needs to equal 550. So let's see, 550 minus 70, well, that's X 80 equals 480. And now we're going to divide that by 80 now instead. Okay, now originally they were going to spend they were going to pay on this for 8 months. Now instead we got X equals 60, and we're set. Okay, so it's going to, or not 60, oops. It's only going to take 6 months now, as opposed to 8 months. So it's going to take 2 fewer months to pay it off. And there we have it.